Good morning, everyone. So welcome to my YouTube channel, and subscribe. So today we are going to see first lecture on asymptotes of curves. Okay. So let's see what is the definition of asymptotes. Let Pxy be an arbitrary point on a curve C. Then a straight line L is said to be an asymptote of the curve C if distance between Pxy and L tends to 0 as x tends to infinity or y tends to infinity or both x tends to infinity and or y tends to infinity. Okay, so this is plus minus infinity. So what are the examples of asymptotes? Examples of asymptotes. You see this one. You take curve fx is equal to 1 upon 1 plus x square. Then what is the graph of this curve or function? This is at 0 it is 1 and it is nothing but like this. Okay. Okay. So graph is this 1 upon 1 plus x square. Maybe because I am drawing this graph by hand, so maybe it will not as accurate it look as it is in real. So nevertheless, this is the graph of. So this is one. Now you see that this curve, when you extending to infinity, this is the distance between the points here, points on the curve, and this straight line is tending to 0. So what is the equation of this straight line? Y is equal to 0. So therefore, y is equal to 0 is asymptote for the curve of the function fx is equal to 1 upon 1 plus x square. Curve means you draw its picture, that is curve. Okay, this is the function. So this is the asymptote. Now second example, we are taking to take this function fx is equal to so here you take y is equal to so you take y is equal to 1 plus 1 upon 1 plus x square. Okay. So y is equal to 0 is asymptote for this curve or function, you can say. So I'm writing y. Okay. Now another example, I'm taking this one. To take this example, y is equal to 1 upon x. Okay. Then what is the its graph? X I'm taking greater than 0. Then what is the its graph? Its graph is nothing but okay. This is tending to 0. Okay, so this is the graph of this one. Y is equal to 1 upon x. You see that this is y is equal to 0 line and this is x is equal to 0 line. So you see that distance between this curve and the points on this curve and this line tends to 0. Same here, you take this line, the distance of between points on this curve and this straight line tending to 0. So x is equal to 0 and y is equal to 0 are asymptotes for the curve y is equal to 1 upon x. Okay. X greater than 0. X is greater than 0 here. Okay. Now you take this example, third one example. So I am taking this example. X square minus y square is equal to a square where a is greater than 0. Then what is the graph of this curve? So this is a, this is minus. So so this is the graph actually, because I am drawing it by hand, so it will not as much accurate. So this is the graph actually. You see, these are the straight line y is equal to x and this is y is equal to minus x. Okay. You see the points on the curve, the distance between this straight line and this curve tends to 0. Okay. And same here, the distance of points here on the curve and this straight line tends to 0. So y is equal to x, y is equal to x and y is equal to minus x are asymptotes for the curve x square minus y square is equal to a square where A is greater than. So what are the types of asymptotes? Types of asymptotes. So asymptotes are three types. Types. Okay. So we know that an asymptote is a straight line y is equal to mx plus c. The equation of line is given by this. Okay. So uh, asymptotes are three types. First type is horizontal asymptote. Horizontal. So if m is equal to 0, then y is equal to c is called horizontal asymptote for the curve. Okay. For the curve. Now, second one is vertical asymptote. So what is the example of horizontal asymptotes? Okay. So what is the example for horizontal asymptotes? We have seen example. You see this one. You see this example. This is y is equal to 1 upon this one. This is 1. So y is equal to 0. So y is equal to 0. Y is equal to 0 is horizontal asymptote for the curve y is equal to 1 plus 1 upon 1 plus 1 upon 1 plus x square. Second example, second type is vertical. If if y is equal to 0 and m is not equal to 0 and c is not equal to 0, then what we have, x is equal to minus c upon m. It means x is equal to d, where d is equal to minus c upon m. Then x is equal to t is called vertical asymptote for the curve. Okay. Put minus c upon m is equal to m so that x is equal to b. Then x is equal to 0 is called vertical asymptote of the curve. You see this example. See this example. This is y is equal to 1 upon x greater than 0. So this is x is equal to 0. So x is equal to 0 is vertical asymptote for the curve y is equal to 1 upon x greater than 0. Third type is inclined, or oblique if both m is equal to non-zero and c is equal to non-zero, then y is equal to mx plus c is called inclined inclined or oblique asymptote for the curve. We see this example. This example. So this is a 0. This is minus a 0. Okay. So this is x square minus y square a square. This is also x square minus y square equal to a square. So this is y equal to x and this is y equal to minus. Sorry, in this only if if m is equal to not equal to 0, then y is equal to mx is called inclined or oblique asymptote for the curve. Only m should be non-zero. Y is equal to x and y is equal to minus x are inclined or oblique asymptotes for the curve x square minus y equal to a square 0, a is greater than 0. So today's lecture up to this. If you have any problem related to this, you can comment on my YouTube channel. Like, share, comment, and subscribe my YouTube channel. So thank you very much for today's lecture. Thank you very much. We will see you in next lecture.